Okay, guys, here's our objective for the day. Okay, hopefully today will be a little more straightforward than it was yesterday, and not maybe quite as confusing. I looked at the IXL, and it wasn't the best, but that's okay. All right. So moving forward, here's our objective for the day. I can find the rate of change and slope from 2 points. Okay. So our keywords today is that we're going to talk about rate of change. We're going to talk about rate of change, and really, that's the same as slope. Okay. Let's copy that down for me real quick. Now, yesterday we talked about K, right? We talked about our K value. And can you guys remember how we found it? How do we find it? Well, remember we said that K was the same as Y over X. So if we had a quick little table, let's just add X and Y, right? 4, 10, 8, 20, right? To find our K value, we would have just taken the 10 and put it on top. Oh, that's fun. Didn't mean to do that. The 10 and put it on top. And the 4 and put it on bottom, right? We talked about yesterday that being the Y over the X. And we could simplify that to, let's see. Take a 2 out of the top, that's going to be 5. 2 out of the bottom, and that's going to be 2. And that would be simplified there. Right? We didn't mention this yesterday, but it's not a bad idea. If you have it as an improper fraction, it'll leave it. That's okay. That'll make more sense when we talk more about slope in the future. All right, so today we're going to make the connection between our K value and rate of change from a table. So we're going from K value to rate of change, which is really the same thing. I talked about it a little bit yesterday. It's really exactly the same thing. Okay, so let's take a look at this problem for a second. Let me make it a little bigger for us. All right. Eve keeps a record of the lawns that she mows and how much money she makes when she does it. Okay? Tell whether the rates of change, or chance, rates of change are constant or variable. Let's talk about what those words mean. Constant, what's constant mean? We talked about that a little bit yesterday. Constant means the same. Variable means different. If they're the same, it's going to be linear, and that's a good thing. If they're not, then we got a problem. But honestly, during your 8th grade year, most of this is going to be constant. Okay, our rate of change is going to be constant. So how can I figure it out? Well, just like yesterday, let's find the rate of change, which is basically the same as K. So I'm going to put my ratios down here for the first time. And we talked about yesterday, this was going to be X, and this is going to be Y. Right? So our Y value for the first one is 15 over 1. Y value for the second term is 45 for 3 longs, 90 for 6, 120 for 8. Now, yesterday we talked about how to find out if those are constant or not. We would just simplify them all, right? And if I simplify and they're the same, then we have the answer. So 15 over 1, we know that's pretty simple, right? 15 over 1, we know that's going to simplify to 15. So I need all of these to be 15 to make sure that they are constant. 45 divided by 3. 15, 90 divided by 6, 15, 120 divided by 8, 15. So I can tell that they're all constant. Okay? So my answer would be constant. And my rate of change, or my K value, okay, my rate of change would be equal to 15. Okay? Everywhere are the 15s. Okay. Next one. Copy this table for me real quick, and let's find these together. Find the rate of change from 1 hour to 2 hours. Okay, so rate of change. Remember, that's going to be this. Anybody seen this symbol before? Change in Y, change in X. Okay, so how far am I changing from Y? How far am I changing from X? From 1 to 2 hours. Here we go. I got change there. 15 to 30 is 15. 1 to 2, 1. Huh, that looks familiar. If I simplify, 15. Okay, what if I do the change from 1 to 4 hours now? Okay, so I have 1 here to 4 hours. How far is it from 60 to 15? 60 minus 15 is 45. So my change in Y is 45. And my change from 1 to 4 is 3. That looks familiar. I think I might have done that one not too long ago. 45 divided by 3 is 15. Now let's do one more, okay? Let's do one more. From 2 to 4. Okay, from 2 to 4, here we go. 30 to 60 is, you said it, 30. And then from 2 to 4 is, by changing x, is 2, which simplifies to 15. The reason why I'm showing this, guys, is that it doesn't matter what points that you pick, it's always going to give you the same answer. Now, the answer is not going to always be 15, okay? That just happened in these first 2 examples. Cool? All right, let's keep moving. All right, all right. Now, here's the next thing, slope. What if we just have 2 points? Okay? You ready for this? All right. Here's our formula that we're going to use today. Okay, you ready? Copy this from a slope. What is it? Here we go. How do we find it? I'm going to write over here just so I have a little room. y2 minus y1, x2 minus x1. Okay? There's our slope formula. This is how we find slope. Copy that for me. And I'll talk about what that means in just a second. Okay? And maybe before we start that, I need to talk about what are my coordinates. Well, right, the first coordinate in order pair is x. The second coordinate is y. All right? So let's take a look at this here. So if I'm going to label these, I'm going to put it right above here, guys. So this is going to be my x1, y1. Okay, because it's my y coordinate, my first y coordinate. This is going to be x2. This is going to be y2. Okay? And we're going to put it in that order every single time. That way I can't ever screw it up. So now I just plug it in my formula. Here we go. y2, so I'm going to start with y2, which is 9. There's y2. y1, which is 5. Okay, so there was y2. There's y1. All over x2, which is 10. And x1, which is 4. Okay, let's solve it now. Now let's just go across the top. 9 minus 5 is 4. 10 minus 4 is 6. I am going to simplify here, take a 2 out of each. Okay, so I got 2 and thirds. Okay, that kind of makes sense. If I go too fast here, pause it so you can get caught up with me. But I want you to work these out with me, okay? All right, let's do another one. Here we go. Let's label them again. Here we go. x1, y1. x2, y2. Now I just fill out my formula. You ready? 17, there's y2, right? There's y2, y2, y1, minus 11. Okay? x2, 15, minus x1, 9. 17 minus 11, 6. 15 minus 9, another 6. Simplify. 6 over 6 equals 1. Okay? All right, let's do a couple more. Couple more here. Okay, we got some negatives, but that's okay. All right, we're going to do this one to the left there. We're not going to do that one. Okay. Let's label it just like before. Here we go. I got x1, y1, x2, y2. Okay, because remember my formula. y2 minus y1, x2 minus x1. Okay, let's plug it in. Let's go to work. Here we go. y2. Okay, y2. Here we go. I got negative 9 minus negative 9 minus y1, which is 1. Okay, now I have x2, which is 5, minus x1, which is a negative 3. Okay, now let's go to work here. Okay, I got negative 9 minus 1. I go back to my integer rules. Same sign, add and keep. Okay, 9 plus 1 is 10. Negative. Right, because I have a negative here. Negative there. Now, we talked about this when we did our one-step and two-step equations last week, okay? If I have 2 negative signs, I really like making them plus signs. I don't like 2 negatives. I don't like being negative. So I got 5 plus 3, 8. Okay? Simplify, take a 2 out of the top, 2 out of the bottom. Negative 10 divided by 2 is negative 5. 8 divided by 2 is 4. And there's my answer. Okay? All right, guys, try these 2 on your own, and then we'll talk about them afterwards, okay? So try these ones on your own. Pause the video, stop it, do what you need to, and get them down, and go to work on your own. And then in about a couple minutes, we will go them together and talk about them, make sure that we got it. Okay? All right, guys, we'll talk to you in a few.